Today's video is going to be covering Chapter 4, Section 1, which is on a matrix operations. We're going to focus on adding and subtracting those matrices together. Some real quick vocab you should know is singular would be a matrix. If you have more than one matrix, it's going to be considered a matrices. And for the dimensions, we have, when you write the dimensions, you're going to write it the number of rows by the number of columns. It's really important that the number of rows is always going to come first. It's going to make a difference. If you hear me refer to entries, I'm talking about the numbers inside of the matrix. And if you have a row matrix, just know that rows go across. So this would be a row matrix. And a column matrix, columns go up and down, so a column matrix would be going up and down. And a square matrix, think about the word square. If it is a square, that means that you have the same number of rows as you do columns. So if you had a 2 by 2, that would be a square matrix. You could have a 3 by 3. 1, 2, 3, 5, 6, 7, 8, 9. So I've got 3 rows and I've got 3 columns. And so forth, a 4 by 4, a 5 by 4, and that continues on, just as long as the number of rows and the number of columns is the same thing. And if you have a 0 matrix, that is when all entries equal 0. Alright, so let's go ahead and get started with adding and subtracting our matrices. It is really important when you are adding and subtracting that you remember that the dimensions of your 2 matrices or 3 matrices must always be the exact same. And if you remember, when we refer to the dimensions, we said the number of rows comes first and the number of columns comes second. So when I look at this first matrix, I have 1, 2, 3 rows, and I have 1 column. So this is a 3 by 1 matrix. 3 rows, 1 column, so I've got a 3 by 1. Because those are the same dimensions, I can go ahead and add those matrices together. And when I add them, I want to add corresponding entries. That means entries that are in the same position. So 1 and 6 are in the same position. 1 plus 6 is 7. 2 and negative 2 are in the same position. 2 minus 2 is 0. And 4 plus 4 gives us 8. Now we added 2 matrices together, so just make sure that you put those brackets around it because your answer is also a matrix. Alright, so we look at our next one and we see that we have the same matrices, or same dimensions again. We've got a 2 by 2 and a 2 by 2. This time instead of adding, we are subtracting. There's a couple different ways you can go about this. One, same entries or corresponding entries. So we've got negative 3 and 5 in the same position. So I would do negative 3 minus 5 to get a negative 8. The only problem with using that method is a lot of times some people will forget to subtract each time and you'll just add the entries. So what I would suggest doing is from the very beginning change the minus to a plus and then add a negative. So the positive 5 becomes a negative 5. Negative becomes a positive, negative becomes a positive, positive becomes a negative. That way you don't have to worry about remembering whether you should add or subtract. So 4 and 2 are corresponding entries, and 4 and 2 gives us 8. 2 and 8 gives us 10, and 0 and negative 4 gives our last entry to be a negative 4. So our resulting matrix is a 2 by 2 as well. Negative 8, 6, 10, negative 4. Looking down at number 3, we have a 2 by 2. Square matrices are always easy to figure out the dimension since it's the same. You don't have to worry about which number goes first. When I look at the second one, remember the number of rows comes first, so I've got 2 rows, 1 column. This is a 2 by 1. We can't add these together because they're not the same dimensions. So if these numbers aren't exactly the same, then you can't add them. Alright, let's move past adding and subtracting and talk about scalars. When we have a scalar, all we're going to do is amplify it or multiply it by that factor. I want to multiply this 2 by 2 matrix by a scalar factor of 2. And all I'm going to do is distribute that 2 in. So 2 times 1 gives us 2. 2 times a negative 3 is a negative 6. 2 times 4 is 8. 2 times 2 is 4. So I'm just distributing the 2, multiplying it every entry by a factor of 2. When we look at number 5, we're going to combine the scalar and the addition subtraction together. So first, I'm multiplying the first matrix by 3. So 3 times 4 gives me 12. 3 times negative 1 becomes negative 3. 3 times 5 becomes 15. And 4 becomes 12. There's my new matrix. And as we said before, when we subtract, I don't want to worry about that negative, so I'm going to distribute a negative 2 each time so I can change that into an addition sign. So a negative 2 times 3 gives us a negative 6. Negative 2 and a negative 2 make a positive 4. Negative 2 and 4 is a negative 8. Negative 2 and 5 is a negative 10. Now, when you are distributing these scalars, make sure that you're keeping the numbers in the same spot that they were. So the 3 becomes a negative 6. The negative 2 becomes a positive 4. Don't mix up where the numbers are located. And then it becomes a simple addition problem. 12 and negative 6 are in corresponding positions. So 12 minus 6 is 6. A negative 3 and a positive 4, that gives us a positive 1. 15 minus 8 gives us 7. And last, 12 and negative 10 leaves us with a positive 2. All right, moving on. Our last topic for today is solving missing values in a matrix. So when I look at number 6, I've got 1, 2, 3, 4. I've got 4 entries. It's a 2 by 2. And my answer is a 2 by 2. And I don't have any operations going on here. I'm not adding, like here I've got one matrix plus the second matrix. I'm just saying that this matrix and this matrix are equal. So I want to find out the missing values that would make that true. So I look at corresponding positions. The 4x is in the same position as the 8. So I know that this quantity has to equal 8 in order for those two matrices to be equal. So I set up an equation, 4x equals 8, divide by 4, and we find that x is equal to 2. Moving on, we see that top right. So I have y minus 7 is equal to 7. Add 7 to both sides, and we find that y is equal to 14. Next, 5 and 5 are in the same positions. There is no variable to solve there. I'm just showing you that they are true, they are equal entries. And last, we've got 2z plus 5 is in the same position as 9. So those two pieces have to be equal to each other. So I want to find the value of z that's going to make the left-hand side equal to 9. We move 5 over. 2z is equal to 4, divide by 2, and we get z is equal to 2. Now that is just if we have two matrices set equal to each other. Now number 7, we're going to add two matrices together. We have what the answer is, so I want to find the missing values that are going to make that true. We know that if we're adding, we're going to add corresponding entries. So 2x is in the same spot as 6, which is in the same spot as 12. So I can create an equation there. 2x, my operation is plus 6 equals 12. Now we solve for x, move the 6 over. 2x is equal to 6. Divide by 2, and we find that x is equal to 3. On to the next one. 4 is in the same position as negative 1, which is in the same position as 3. So 4 plus a negative 1 is equal to 3. 4 minus 1, 3 equals 3. Now there is no variable to solve there, and when you're doing your homework or on quizzes and tests, you don't have to show me this. I just want to show you that so that you can see that every single entry in your matrices should follow the same rules. So then we see that 8 and 2 and 10 are the same. 8 plus 2 equals 10, and we see that that is true. And last, 5y and 3, so 5 plus y is equal to 3. Move the 5 over, and we get that y is equal to a negative 2. Alright, number 8 is going to be our last problem, and we're going to combine together the scalar, the adding, subtracting, and the solving for a missing variable. What I want you to do now is I want you to press pause and try this problem on your own and see how well you do. So press pause now, and then when you're done, press play to see if you were correct. Alright, let's see how you did. First, there's two ways you could have approached this. One, you can add the two matrices together inside the parentheses and then multiply by 2, or you can multiply each entry inside the parentheses by 2 first and then add. I did the second method. So I multiplied 3x by 2 to get 6x, 2 by negative 1 to get negative 2, 2 by 8 to get 16, 2 times 5 to get 10. And then I distributed 2 times 4 to get 8, 1 times 2 to get 2, negative 4, and got the negative 2y. You're not going to multiply that negative 2 by the 26, 0, 12, and 8 because that's what it's equal to, and it's outside of the parentheses. So once I multiplied everything by 2, I added corresponding positions. 6x plus 8 is 26, and then I solved to find that x was equal to 3. Negative 2 and 2 and 0, there is no variable, but I see that it is true. 16 minus 4 equals 12. That again does not have a variable, but it showed that it still held those properties to be true. And then last, 10 minus 2y is equal to 8, and I solved and I found that y was equal to 1. Just don't forget that when you're doing a quiz or test, you don't actually have to show me that. I'm just showing you that all 4 positions are still going to hold their true value. Alright, and that's it for your video today.